Good evening. This is Slew. I'm Bob Berman here on this exciting night during the opposition of the planet Mars. And for the next half hour, we'll be looking at live images and very recent images taken with the Slew telescopes. We'll also have a very special guest who I will introduce in just a couple of minutes from now as we look at something that we've waited 4 years for, and that is the planet Mars coming to almost its closest approach. And the reason we have to say almost is that in a mere few days from now, we're going to have a double whammy, a total eclipse of the moon visible from the entire mainland United States. And on that same night, Mars will actually come closest. And this brilliant blue star will be next to the red eclipsed moon. And the moon goes into Earth's shadow, and Earth's shadow isn't black, but it's red. And oh, strange stuff is going to happen. And that's all coming up on Monday night. We're going to actually divide that into two parts. We'll have a close encounter with Mars starting at 7 p.m. Pacific time, 10 p.m. Eastern time. And then later on at 2 in the morning Eastern time, set your alarm, 11 p.m. Pacific time. Then we'll start with the live coverage of the total lunar eclipse. There's so much attention on this, and deservedly so. It's a very, very special event. Tonight, we are focused on the Martian opposition. And before we go further, I want to qualify the difference between an opposition and its closest approach. They're often the same when we say that a planet outside of our orbit, every planet except for Mercury and Venus, comes to opposition. That's usually when it's closest, when there is a lineup between the Sun, the Earth, and that planet. But the Martian orbit, because it's both tilted, it has a slant to its flat plane, to the plane of the ecliptic, and even more importantly, it's out of round so much so that the actual lineup with the sun, being opposite the sun, can miss the exact date of its precise closest point. And that's why that will be next Monday. But tonight is pretty darn close. It's almost there. This is the Martian opposition. So this is what astronomers use usually to really get excited and look at the planet. So what we're looking at now is a slew image of the planet Mars. I want to keep this image here. We just took this here at SLU using the Prescott Observatory, one of our partner observatories, showing amazing detail. And rather than me talk about it, I mean, Mars has had history with imaginary life and possible real life on Mars. But who better would be, speaking about this, would be Dr. David Grinspoon. Now, this is an American astrobiologist who is curator of astrobiology at the Denver Museum of Nature and Science. But what impresses me is that he was awarded the Carl Sagan Medal by the American Astronomical Society for the public communication of planetary science. And he's also the NASA Library of Congress chairperson in astrobiology. So when we say astrobiology, we're talking about life out there. And when we talk about life out there, Mars comes to mind as well as a number of other objects of the solar system. So that's what we're going to be focusing on tonight. Without any delay, then, let me say hi to Dr. David H. Grinspoon. Good to have you, David. How are you doing tonight?
Hi, Bob. Good evening. I'm doing fine, and I'm really happy to be here to join you and all of our visitors to talk about this the wonderful occasion of Mars coming in close here.
And you, as an astrobiologist, and Mars being so associated with War of the Worlds, that famous radio script written by Howard Koch and delivered by Orson Welles, and all the other Jules Verne and other invasion from Mars movies. What does that do in your mind when you look at a picture of Mars? And I know we're going to zoom in and talk about curiosity and look at the surface in a little bit, but free associate. What comes to mind when you see Mars here? So close.
Well, it's a romantic image for me looking at Mars like that. I mean, I think we've got so much history going back to, like you say, War of the Worlds and Percival Lowell and these visions we've had of Martians and possible past civilizations and past climates on Mars. And then in the age of science, of course, we don't see canals and in failed civilizations, but we do see perhaps a failed biosphere, and we do see, if not dried up canals, we see dried up riverbeds on Mars, and there is this sort of sense of a hidden past that we're trying to uncover. And then, in my own life, I just associate Mars with planetary exploration and the early missions, and then the Viking happened when I was a teenager. My first ever research project as an undergraduate was working with the brand new Viking pictures of Mars, and then of course all the wonderful later missions we've had, and now we're there with Curiosity on the surface, and still exploring and trying to uncover that past. So to me, it's just sort of multi-layered mystery, and I can't separate it from also just sort of the romance of all that history that we have.
Yes, and as long as you're mentioning those missions from the 70s, the earlier Martian uh, missions, wasn't there an ambiguous result, some kind of tagged radiation and carbon release experiment that gave very intriguing and ambiguous results?
Yeah, it's true that the Viking mission in '76, we had two landers, Viking 1 and Viking 2. In some ways, the most ambitious planetary missions ever launched. They had these really complex experiments, these Viking biological experiments that sort of scooped up Martian soil and brought it inside and did all these things to see if we can provoke any kind of a biological response in that soil. And yeah, one of the experiments, which was called the labeled release experiment, did produce results which at first seemed very consistent with the presence of life. Basically you take this Martian sample and you feed it some of this nutrient which they called chicken
Chicken
soup,
soup.
which
Yes.
yeah, which is basically just sort of every kind of enticing organic molecule that you think these possible microbes might want, and you label that stuff, meaning some of the carbon in the chicken soup is with radio labeled carbon, so it's a heavier isotope, so that then you can see where it goes. And if that stuff then starts sort of exhaling CO2 that has that label in it, that labeled carbon, then you think that something has eaten that soup and is breathing out the CO2. And that's exactly what happened. That sample started bubbling out CO2 that had the radio label in it. So it was as if some metabolism was interacting with that. Now, upon further analysis, it really didn't seem like it had the right pattern of release of a biological response. It seemed much more like some kind of active chemical response. And then the other thing that sort of dulled the enthusiasm was the fact that there was no organic matter in that soil that they could detect with this other instrument, the mass spectrometer. So it was, the consensus analysis was that it was not in fact life detected by that labeled release experiment on Viking. But there are a couple holdouts. The original lead investigator from that experiment is still around. Gil Levin is his name, and he still believes that instrument found life on Mars. And so, most of us don't think so, but that story, it does speak to us of how difficult it is to develop and design a definitive experiment to find life on another planet when we know so little about what life really is as a universal process.
There's been clues, haven't there? And then, if I remember, not too many years ago, we had that Martian meteorite, ALH 84001, and NASA itself, JPL at least, announced that there were fossils of life. Remember that?
Yeah, sure do. That was just another amazing moment in this whole sort of saga we've had in our relationship with Mars, and discovering things and getting excited and then realizing we had misinterpreted. And that's another one. Like you said, there are these meteorites that come from Mars, and that part of it is true. We have really good evidence now that we have a dozen or so rocks on Earth that come from Mars, and that in itself is kind of mind blowing. But then a team of NASA scientists analyzed some structures in one of those meteorites, the ALH 84001, that was this meteorite that was found in Antarctica. and they saw what they thought were clues to actual microfossils, ancient life. They saw structures and chemical signatures that they thought made a good case for there having been life in this sample, and it was really a big deal. There was a press conference with President Clinton.
Right.
Then
Did
this is
Dan Gold was behind that, wasn't he?
yeah. I mean, it was a big deal. They announced this evidence, and that discovery was actually pivotal in the development of the astrobiology program at NASA. Because even though the consensus ultimately, again, was that, well, no, we probably haven't found evidence for life on Mars yet, it got a lot of people to think, well, why not? What is so absurd in this idea, given what we know about the conditions of early Mars and what we know about the requirements for life? And so, even though that particular story of that evidence maybe was kind of refuted by a lot of further analysis, I think that did open up a lot of people's minds to the idea that we should be thinking about life on early Mars and how we would find it and what its signature might be.
This is Dr. David Grinspoon, and he happens to be the chair of astrobiology for the Library of Congress. I'm Bob Berman, and this is part of our slew coverage of this night's historic, meaning it's been 4 years since this happened, over 4 years, close encounter with Mars. The opposition of Mars is occurring tonight. I want to remind everybody that on Monday night, this coming Monday night, we're going to have a night full of further Martian programs, because that will be the precise night of the closest approach on the same evening, the same night that we have a total eclipse of the moon, and the moon will come a strange red color. It's going to really be a bizarre experience. We're going to have some amazing people that night too as our guests. We'll have Timothy Ferris, the best-selling author of Seeing in the Dark and professor emeritus of astronomy at UC Berkeley. We'll have documentary filmmaker Duncan Kopp joining us from London, and that's going to be a fun night coming up this Monday night. I want to also
Oh, that
mention here
sounds like a
that
party.
oh, that's going to be a party. You've got to join us. That's going to be great
Mars
coming
party.
Monday night.
Yeah.
Yep. Ocean now for SLU. Anybody who joins SLU membership, which means you can actually control the SLU telescopes. Look at this image we're seeing. You can actually see this yourself, make the telescopes point anywhere you like. Search for life on your own. We're going to be looking at a few other places in a few minutes where members have been scouring the universe, not necessarily looking for life, but places where life could exist. I'm going to bring David back into that conversation. And if you join SLU the next day, you get 1 month free. So there it is, a little bit of a promo and an offer that only exists tonight. So while we're talking about that, we've been looking now at a recent live image of the planet Mars on this occasion of its opposition tonight, and just about at its closest approach. Now let's zoom into the surface of Mars, some images taken with the Curiosity rover. And as we look at these pictures from the surface of Mars, of course, not taken through our SLU telescopes, but courtesy of NASA and JPL, let's bring Dr. Grinspoon back into the conversation. What are the results so far, and are you discouraged by the not finding anything waving back at us yet?
No, I'm not discouraged. Remember the point of this Mars Scientific Laboratory, this Curiosity rover, is not even really to find life. That's not its mission. Of course, we're keeping our eyes open in case something does wave back. But the point of this is really to try to understand if there are organics that might be preserved that we could study that are really clues to early habitability on Mars.
And when you
And
say organics, what do you mean? Explain it to the
yeah,
people.
thank you for asking me because I should unpack that. So, of course, the basis of life, certainly life as we know it on Earth, is organic chemistry dissolved in water. And when we say organic molecules, we mean really complex carbon molecules. So, chains of carbon attached to each other and attached to other elements, hydrogens, oxygens, nitrogens, in these structures that allow the the um, the machinery of life to operate. That's how it works on Earth, and that's how we picture it working elsewhere. A lot of smart people have tried to imagine other chemistry that might do biology and haven't really come up with anything. And so, as of now, our search is focused on organic molecules, and the preservation of organics requires certain kinds of environments. That Mars is bathed in really intense radiation from the sun and from galactic cosmic rays. So you're not going to find these organic molecules just sitting on the surface. They're going to be buried, or they're going to be in certain kinds of environments. Certain kinds of minerals like clays can preserve organics very well. And that's really sort of the holy grail of this mission, is trying to find organic matter and trying to characterize the kinds of environments that might be preserving it. And so, we're really just getting started. We're heading towards those mountains we see off in the distance. It's called Mount Sharp, this big mound in the middle of this crater. There, you can see it there in the distance, this enticing mountain. But what we found so far confirms the picture that we're in basically a giant ancient lake bed. It's a giant crater, and these sediments that we're driving over, we found tons of evidence now that it really is an old lake bed, and that a lot of these rocks have been formed and altered by water in a lot of ways. A lot of these pebbles that you can see are pieces of these conglomerate rocks that are, they're lake rocks. They're rocks that have been moved by water and then deposited and formed new rocks that are basically the result of movement of sediment by water. And so we're in the kind of environment that we were seeking, and now, because of the fact that we have this mobility, we can look what's on the horizon, and pick the locations within that crater that we want to go to, where the rocks seem interesting, and drill and do experiments. And the other great thing we've got going for us, by the way, with this mission, is that we've got these wonderful orbital assets, so we actually can image from orbit and see the big picture and see what the spectra is of the rocks. And the combination of the rover on the ground and the orbiters that we have at the same time is really a powerful tool for exploration, because we can always see the landscape from that overhead perspective and figure out where we're going.
Wonderful. And for our listeners and viewers who are looking at these images from the surface of Mars and thinking, "Hey, that looks like the desert Southwest or something. It looks very familiar." Let's remind everybody that if you were on the surface of Mars, number one, the air is only 1% as dense as it is on Earth. You can't breathe it. There's nothing to breathe. And what little there is carbon dioxide. So it's easier to live in Antarctica or on a bubble under the ocean than it is on the surface of Mars. Plus, as David just pointed out, there's radiation bathing the surface, cosmic rays, mostly protons. 90% of those are heavy protons. That's, they're each 1,836 times heavier than electrons. Bam, 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 pummeling the surface. You don't want to be there. David, I once read that an astronaut on Mars on a 2-year mission could suffer so much radiation that they would lose between 12 and 40% of their brain, their neurons. Now, that's not good for even us smart people, is it?
Wow, that's quite a figure. I've not heard it put in those terms of losing the neurons like that, but that is a daunting thought. Although, yeah, for some of us, maybe, losing a few might just slow us down a little. But yeah, the radiation environment there is intense, and it's would be one of the probably the major health threat for future astronauts, especially if there was a solar storm, because Mars doesn't have the kind of thick atmosphere and the radiation belts, the magnetic field that Earth has. It sort of fends off the sun's influence. And so one thing you would want to do if you were going solar storm or something, that you could miss the worst of that radiation. And the best way to do that would probably just be to go underground and be under a few meters of rock. Dig, basically have a underground shelter that you could go into when there was a solar storm approaching.
Right. Perhaps someday we'll do that. I'm Bob Berman, and this is our special guest, David Grinspoon, who is the chairman of the astrobiology for the Library of Congress, among other things. We are covering our live, and we're looking at the image of Mars now. This is our slew coverage of this opposition of Mars. If you're just joining us, opposition is when the sun and the Earth and Mars form a straight line in space. Traditionally, that's the night of closest approach. But it just so happens the actual night is coming up on Monday night into the wee hours of Tuesday morning, when Mars will come close and there will be a total eclipse of the moon. We will have special guests that night and have 4 hours of coverage. So you definitely don't want to miss that. That's for sure. Now, while we're looking and talking about life, let's look at some places elsewhere in the universe that SLU members using the SLU telescopes have been using. And I'd like David to comment on the possibilities of life, or the precursors of life, existing among these places. Let's start with the Orion Nebula. This is a member image just taken recently. Boy, is that beautiful. 1,500 light years away. It's the nearest of the major star nurseries where new baby stars are being born. And when you look at this, you being an astrobiologist, Dr. Grinspoon, what comes to mind when you see this?
Well, yeah, as an astrobiologist, we think in terms of cosmic evolution, right? Like how do we and how does life on Earth fit into the bigger picture of the transformations occurring in the universe? So obviously, as you mentioned, we're seeing an area of star birth, and the birth of stars is a major part of that, and the recycling of elements in successive generations of stars, making that carbon and that nitrogen and all those other juicy elements that go into the what we call the biogenic elements to mix in with all that good old hydrogen that's been there from the beginning. So we're seeing element factories, but then also all that glowing material. We're seeing clouds of interstellar dust, some of which is being pushed and pulled by those stellar winds into forming new solar systems. And we know now that interstellar dust is a very rich source of molecules, and in particular is rich with organic molecules, which we were talking about earlier, the stuff of
Wow.
life, carbon molecules. And through the wonders of spectroscopy, where we use the wavelengths of light to analyze the composition, to see what molecules are in this material. The great thing about spectroscopy is you can see anywhere in the universe. You can tell what stuff is made out of, and we've learned now that interstellar dust is in fact a very rich source of organic chemistry, and that it may be that that's how some of the organics got into our solar system that made the life here. And the implication then is that is also forming the material of other solar systems, and that the stuff of life exists throughout the universe, and that anytime you have a planetary system forming, it's going to be seeded with these molecules that, at least here and perhaps elsewhere, have led to life.
So panspermia is no longer science fiction, is it?
Yeah, well, I mean, you don't need. I mean, literally, panspermia is the transfer of life from one living world to another, and we don't necessarily need to imagine the seeds of living organisms moving from place to place, because you can have the building blocks of life moving throughout the universe. So in a certain sense, it's panspermia, but where the seeds are just the molecules themselves that kind of permeate the universe.
Right. Now, from this image, we've just been looking at the Orion Nebula as imaged by our SLU members using the SLU telescopes. It's their right. When you're a member, you can make the telescope point anywhere. Let's look at someplace else that the members have been looking at recently, and this is the great colliding galaxies. At least they're in near collision, a small galaxy at the top and the main one at the bottom. The main one is called M51, or the Whirlpool Galaxy. The one at the top is NGC 5195. And whoa, is this beautiful? We're talking about solar systems. David was just talking about life on solar systems. Well, here we have hundreds of billions of probable solar systems. We're looking at 100 billion stars and probably an equal number of planets in here. And if you had to bet the farm on it, would you say that life is likely in this scene that we're looking at right now?
Yeah, again, my first thought on looking at this is, as you said, just how beautiful it is. It's a stunning image, and absolutely, we are. I can't imagine that we are not seeing photons from stars that have worlds of life around them. If you're looking at the kinds of numbers you talked about, if you're looking at hundreds of billions of worlds here, what kind of universe would it have to be to have all those worlds be barren? Until we know that there is life out there, we don't know. And as scientists, we're conservative and we need evidence and so forth. But still, statistically, if unless you imagine that there is something just like so ridiculously unique about Earth, and we haven't found anything that is, and we've been studying Earth and other planets pretty carefully, then you just have to conclude that the most likely conclusion is that a scene like this is rife with planets that are just full of life.
Good. And now from this distant view taken by slew telescopes, we're going to pull back to the subject of tonight's show, the opposition of Mars, as we look at now an image of Mars taken by the slew uh, satellite telescope in Prescott, Arizona, and we want to thank Prescott Observatory Director Matt Francis. Look at this beautiful image of Mars. Look at that tiny little polar cap at the north. It's shrinking because it's summer right now on Mars in the northern hemisphere. And if I remember correctly, and I'll ask you just to confirm this, David, the northern polar cap, at least back when I studied this stuff, was mostly water ice, and the southern polar cap was mostly dry ice. And before I get you your yay or nay on that to see if I'm wrong or not, want to remind you a free month of SLU. Anybody who becomes a member in the next 24 hours, that's what you'll get as our thank you to you. So, was that true, or has that been revised since I went to
No,
school?
it is true. It's strange. There's an asymmetry on Mars between the composition of the two caps. They are both have a lot of CO2 in them, but actually I think it's backwards from the way you said it. But I believe it's the southern pole has this residue of water, and the northern pole is almost all CO2. My apologies if I've got it backwards now, but they are different, which is fairly strange. And I mean, Mars has a lot of interesting north-south asymmetries. Actually, the the southern hemisphere tends to be higher altitude. You've got the highlands, and the northern hemisphere, lower altitude, you've got these smooth lowlands. And it's actually, it's substantial. There's a few kilometers difference in average altitude, and then the seasons are quite different. As you mentioned, it's now summer in the north, and as we can see with this image, like as you pointed out, the northern polar cap is tiny. We've just passed the summer solstice on Mars in the north, and in the southern hemisphere, the summers are shorter on Mars, and in the northern hemisphere, the summers are not as hot but longer. And it has to do with that what you mentioned at the beginning of the show, that fact that Mars's orbit is not circular. It's highly compared to Earth. It's fairly elliptical. And in southern summer, Mars comes closer to the sun, and that means by Kepler's laws of planetary motion, it's moving faster as well. So that's why those southern summers are hot and short on Mars, because it's moving faster and it's in a little bit closer to the sun. So right now we're in the middle of a less warm but longer northern summer on Mars.
Excellent. As we look at this image, I'd like to, not to discourage anyone, but anyone using a backyard telescope on Mars is likely to be disappointed because even though we've waited 4 years for Mars to come this close, it's still only 15 arc seconds across. Now, one arc second is the size that a $quarter coin would show at a distance of about 4 miles. So this is a tiny, tiny little disk, and we're doing very well at SLU to show you all this detail. By comparison, during the historic close approach of Mars on August 28, 2003, Mars was 25 arc seconds. That is almost twice as large. And of course, you're going to see a lot more detail when the disk is twice as large. But even what we're seeing, David, you'd like to narrate what those dusky features are, or what those white spots are, other than the northern polar cap?
Yeah, well, I mean, one of the great things about observing Mars, and one of the reasons it's fascinated people throughout our history as telescopically observing creatures, is that it's always different. It's changeable place, has this animated appearance, which is probably partly what's fueled our fantasies of Martian life over all these decades and centuries. And right now we can see some of these white puffy features closer to the equator are clouds, and the clouds, of course, come and go, and you get both water clouds and carbon dioxide clouds. That is water ice and carbon dioxide ice on Mars, and then, of course, you can see on the surface there are bright areas and dark areas, and really what you're seeing mostly is varying amounts of dust. The dust tends to be bright, and it blows around on Mars, and so you have features that kind of move around in shape over the years. And the atmosphere, of course, also changes over time and with the seasons, because it's sometimes dustier, sometimes less dusty, and then famously every once in a while, Mars will kind of freak out into a global dust storm, in which case you would not see any of this surface detail at all. You would just see a bland, it looks like Titan.
That's right. And it even
fuzzy.
changes. You could see it from Earth because Mars turns from kind of pumpkin colored to more yellow colored in the sky. Just with the naked eye, you could tell that a global dust storm is going on, right? It's
Yeah.
amazing.
Yeah, it is amazing. Unfortunately, it's not doing that now because we can see all this great detail on the surface.
Now, if you'd like to talk to Dr. David H. Grinspoon, and as I've mentioned many times, he's a rather famous astrobiologist. He's the chair in astrobiology for the Library of Congress, among other things. You could reach him on his Twitter handle, which is, believe it or not, Dr. Funky Spoon. Right. I'm just really so grateful for you to join our program tonight. It's been so much fun to watch Mars during this opposition, and want to remind everybody that on Monday night we're going to have a double-barreled show. First, we're going to have the closest approach of Mars. It's even going to be slightly larger than this, and that's going to start at 10 p.m. Eastern Time, and then just a few hours later, at 2 a.m. Eastern Time, the total eclipse of the moon, when the moon will go through a bizarre series of make-believe phases and then finally turn, in all probability, a coppery red. You never can tell. The unpredictability of the color of the moon when it's totally eclipsed is one of its draws, actually, and that's all happening on Monday night. So you will hopefully join us then. And David, I'd love to have you back sometime on the show, and I hope you'll join us again, especially when we're talking about life on other worlds or astrobiology. Thank you so much for joining us.
It would be my pleasure to join you again. This has been really fun and really great talking with you, and thank you so much for having me on the show.
Oh, it was a pleasure. For SLU, I'm Bob Berman. Good night.
all of our visitors to talk about this the wonderful occasion of Mars coming in close here.
And you, as an astrobiologist, and Mars being so associated with War of the Worlds, that famous radio script written by Howard Koch and delivered by Orson Welles and all the other Jules Verne and other invasion from Mars movies. What does that do in your mind when you look at a picture of Mars? And I know we're going to zoom in and talk about curiosity and look at the surface in a little bit, but free associate. What comes to mind when you see Mars here, so close?
Well, it's a romantic image for me looking at Mars like that. I mean, I think we've got so much history going back to, like you say, War of the Worlds and Percival Lowell and these visions we've had of Martians and possible past civilizations and past climates on Mars. And then in the age of science, of course, we don't see canals and
Position and its closest approach. They're often the same when we say that a planet outside of our orbit, every planet except for Mercury and Venus, comes to opposition. That's usually when it's closest, when there is a lineup between the Sun, the Earth, and that planet. But the Martian orbit, because it's both tilted, it has a slant to its flat plane, to the plane of the ecliptic, and even more importantly, it's out of round so much so that the actual lineup with the sun, being opposite the sun, can miss the exact date of its precise closest point. And that's why that will be next Monday. But tonight is pretty darn close. It's almost there. This is the Martian opposition. So this is what astronomers use usually to really get excited and look at the planet. So what we're looking at now is a slew image of the planet Mars. I want to keep this image here. We just took this here at SLU using the Prescott Observatory, one of our partner observatories, showing amazing detail. And rather than me talk about it, I mean, Mars has had history with imaginary life and possible real life on Mars. But who better would be speaking about this would be Dr. David Grinspoon. Now, this is an American astrobiologist who is curator of astrobiology at the Denver Museum of Nature and Science. But what impresses me is that he was awarded the Carl Sagan Medal by the American Astronomical Society for the public communication of planetary science. And he's also the NASA Library of Congress chairperson in astrobiology. So when we say astrobiology, we're talking about life out there. And when we talk about life out there, Mars comes to mind as well as a number of other objects of the solar system. So that's what we're going to be focusing on tonight. Without any delay, then, let me say hi to Dr. David H. Grinspoon. Good to have you, David. How are you doing tonight?
Hi, Bob. Good evening. I'm doing fine, and I'm really happy to be here to join you and all.
Good evening. This is SLU. I'm Bob Berman here on this exciting night during the opposition of the planet Mars. And for the next half hour, we'll be looking at live images and very recent images taken with the SLU telescopes. We'll also have a very special guest who I will introduce in just a couple of minutes from now as we look at something that we've waited 4 years for, and that is the planet Mars coming to almost its closest approach. And the reason we have to say almost is that in a mere few days from now, we're going to have a double whammy, a total eclipse of the moon visible from the entire mainland United States. And on that same night, Mars will actually come closest. And this brilliant blue star will be next to the red eclipsed moon. And the moon goes into Earth's shadow, and Earth's shadow isn't black, but it's red. And oh, strange stuff is going to happen. And that's all coming up on Monday night. We're going to actually divide that into two parts. We'll have a close encounter with Mars starting at 7 p.m. Pacific time, 10 p.m. Eastern time. And then later on at 2 in the morning Eastern time, set your alarm, 11 p.m. Pacific time. Then we'll start with the live coverage of the total lunar eclipse. There's so much attention on this, and deservedly so. It's a very, very special event. Tonight, we are focused on the Martian opposition. And before we go further, I want to qualify the difference between an opposition